Modern military doctrine traditionally follows a strict axiom: advanced engineering and overwhelming technological superiority dictate the outcome of a conflict. Mass-produced, disposable systems are currently breaking that model. These kamikaze drones use simplistic mechanical components and off-the-shelf electronics to achieve strategic effects. A coordinated swarm is a low-cost operation. The total expenditure for mass deployment reaches approximately $3 million. Neutralizing that exact swarm requires advanced radar and high-performance aircraft. The interception cost scales rapidly, reaching $1.5 billion. This expenditure is driven by a reliance on kinetic interceptors. These missiles are masterpieces of engineering, but they carry price tags ranging from hundreds of thousands to millions of dollars per shot. Firing a $1 million interceptor to down a $20,000 drone is a mathematical dead end. In a protracted conflict, the attrition favors the cheaper side. This cost-exchange ratio effectively turns a military's own defense budget into a target. An adversary can bleed a technologically superior power of its capital simply by forcing it to respond to low-cost threats. Three variables drive this shift: the scalability of attritable technology, the inherent fragility of global military supply chains, and the misaligned profit structures of the defense industrial base. In this environment, military dominance depends on economic efficiency and the clinical application of asymmetric attrition. The legacy defense procurement model produces exquisite systems, platforms prioritizing unmatched performance and survivability over volume. This Reaper drone is a prime example. At $30 million per unit, its unmatched capabilities ensure it is produced in very low volumes. Defense budgets are increasingly consumed by the rising costs of sustainment and maintenance for aging fleets, leaving little room for innovation. Capital for new acquisition is further diluted. Funding to rapidly produce low-cost, attritable drones often reaches near zero. This budgetary constraint is mirrored by the structural incentives within the private defense industrial base. SIPRI data shows top contractors rely heavily on state spending, with companies like Lockheed Martin deriving over 90% of revenue from defense. They maintain margins through multi-billion-dollar R&D contracts. Mass-producing low-margin disposable hardware offers little financial incentive. Pivoting a global aerospace corporation to manufacture $10,000 kamikaze drones actively undermines their existing high-margin contracts. This market gap forces governments to seek out and incentivize entirely new, decentralized industrial bases that can build at scale. Weaker powers frequently bypass the traditional industrial complex by utilizing commercial off-the-shelf components and agile, software-defined manufacturing systems. When a nation's industrial base is optimized exclusively for high-margin, exquisite platforms, it becomes a strategic liability in a war of high attrition. Tactical superiority on the very front line is functionally irrelevant if the logistics enterprise fails to deliver critical supplies. This table illustrates the 10 classes of supply required to maintain a modern military force. High-intensity conflict depends on two critical bottlenecks: Class V, encompassing ammunition and munitions, and Class 9, consisting of repair parts. Historically, militaries managed supplies through the Iron Mountain strategy, aggregating massive stockpiles in centralized rear echelon depots. Long-range precision-guided swarms have made these safe rear areas a relic of the past. In an era of contested logistics, centralized stockpiles are primary, highly vulnerable targets. A single successful strike can paralyze an entire theater of operations. This physical vulnerability is mirrored by the digital vulnerability of the modern supply chain. Modern logistics are entirely dependent on digital infrastructure for routing, inventory tracking, and financial clearing. Adversaries utilize asymmetric cyber warfare, like DDoS and ransomware attacks, to paralyze digital networks. The 2017 WannaCry attack demonstrated how quickly these disruptions spread globally. Corrupting the digital routing data of a supply network is as effective as destroying physical assets. Without data, the supply line stops moving. Adversaries no longer need to engage a superior military directly if they can digitally and economically starve its supply chain. Survival in this environment mandates a pivot from rigid, centralized pipelines towards decentralized, adaptable networks. The legacy hub-and-spoke model is brittle. The destruction of a single central hub can collapse the entire network's ability to function. Military planners envision an AI-driven mesh network. Distributing supplies across hundreds of smaller nodes removes single points of failure. Managing this requires AI to dynamically route flows. When nodes are interdicted, the system instantly recalculates new pathways to bypass disruption. This automated resilience is critical for maintaining the flow of Class 5 munitions to the tactical edge in a contested environment. To address the Class 9 repair parts bottleneck, the military is moving toward additive manufacturing, or 3D printing. Instead of shipping a finished component across a contested ocean, the logistics network transmits a secure CAD file to a forward position. Producing components at the tactical edge shifts the logistical burden from finished parts to raw material feedstock and power. While these still require a physical supply line, the complexity and vulnerability of the network are significantly reduced. This approach reduces the overall physical footprint, requiring fewer cargo ships and vulnerable convoys, while accelerating the repair cycle for frontline equipment. In the era of swarm warfare, the secure transmission of digital data has become as critical as the physical transport of munitions. This brings us back to the unsustainable cost exchange paradox we identified at the start. By transitioning from expensive kinetic missiles to directed energy weapons like lasers, the cost of defense drops from millions of dollars per interception to just a few dollars per shot. Efficiencies gained through AI-routed networks and localized manufacturing repair the mathematical imbalance of modern attrition. The logistics of modern conflict now preclude victory through unoptimized industrial dominance or uncontested global movement. Success in future conflicts depends on the ability to mass-produce and sustain resilient, attritable systems, rather than a handful of exquisite platforms. Geopolitical influence is increasingly anchored in the clinical, unsentimental economics of the supply chain that sustains the fight.